Hello, Advanced Year 7 people. This exercise is not compulsory. It is not going to be on your test or final examination, but it does have some useful skills in it for those of you who wish to challenge yourselves a little bit. So let's go through these questions here. So we're talking about number patterns. Number patterns are also known as sequences. And each number in a sequence is called a term, just like we had algebraic terms before. Each number pattern has a particular starting number, and terms are generated using a particular rule. So there's a lot of different types of rules that you can have. So here are some strategies to determine the pattern involved in a number sequence. So the first strategy is to look for a common difference. Okay, so are the terms increasing or decreasing by a constant amount? If we look at this example here, 2, 6, 10, 14, 18, we can see that those numbers are definitely increasing. Is the amount that they are increasing constant? Well, between 2 and 6, we're adding 4. We add 4 again to get to 10, add 4 again, add 4 again. So yes, they are increasing by a constant amount, and the rule that we have is that each term is increasing by 4. Okay, next type of question is to look for what is called a common ratio. Now, common ratio means to be multiplying or dividing by a constant amount from one term to the next. So not adding or subtracting, multiplying or dividing. So for example, let's look at this sequence here. We have 2, 4, 8, 16, 32. Okay, they're getting bigger. So that means we're going to be multiplying. Okay, to get from 2 to 4, we multiply by 2. Multiply by 2 again, we get to 8. Multiply by 2 gives 16. Multiply by 2 gives 32. So that pattern works. The rule would be that each term is double the previous term or multiplied by 2. So each term is multiplied by 2. Next type. Looking for an increasing or decreasing difference. Okay, so for example, we have the pattern 1, 3, 6, 10, 15. So the first two terms we're going up by 2, then we're going up by 3, then we go up by 4, and then we go up by 5. So we are adding something on each time, but the amount that we are adding on each time is increasing by 1. So the rule for this pattern is that the amount increases by 1 each term. Okay, next one. Looking for two interlinked patterns. Is there a pattern in the odd number terms and another in the even number terms? We don't always have to look from the first to the second term. Perhaps there is something relating the first, third, fifth, etc., and then the second, fourth, sixth. Okay, so if we look at the ones that I've highlighted in yellow, 2, 4, 6, they are going up by 2s. If we look at the green ones, 8, 7, 6, they are decreasing by 1. Okay, so there is 2 different patterns happening there. The rule for this pattern is odd numbered terms, meaning the first, third, fifth terms, increase by 2. Okay, then the even numbered terms, which are the ones that are in green, decrease by 1. Okay, next one. Looking for a special type of pattern. Could it be a list of square numbers, prime numbers, Fibonacci numbers, etc.? So there's other types of number patterns that are out there. So here is an example of one such pattern: 1, 8, 27, 64, and 125. Now this pattern is actually our cubed numbers. And what that means is if we took the very first position number 1, that is the same as 1 cubed. 1 cubed means 1 times 1 times 1, which is 1. If we look at the second number, so number 2, 2 cubed is 2 times 2 times 2, which makes the 8. The next one is 3 cubed. 3 times 3 times 3 makes 27. Next one's going to be 4 cubed, and then 5 cubed, and so on. So there are many different ways of making sequences, and you need to be able to try and find and complete the patterns. So here's a couple of extra examples for some practice questions. Number 1, find the next 3 terms for these number patterns which have a common difference. So I'm telling you there's a common difference. We're either adding or subtracting something here. So for part A, we're going from 8, we're going up, so it's going to be adding something to get to 18, so it's going to be adding 12, isn't it? If I add 12 again, I do get to 30. Add 12 again, I get to 42. So each one of these here, I'm adding 12. Okay, so I now need to add 12 to find these remaining ones. 42 plus 12 makes 54. Plus 12 again makes 66. Plus 12 again makes 78. Okay, part B. These numbers are obviously going down: 99, 92, 85, and 78. So we're going to be subtracting something. To get from 99 to 92, we would need to subtract 7. If I subtract 7 again, I do get 85. Subtract 7 again, and I get 78. So I'm going to have to keep subtracting 7 to find these missing numbers. 78 minus 7 makes 71. Minus 7 again makes 64. Minus 7 again makes 57. Okay, question 2. Find the next 3 terms for the following number patterns which have a common ratio. Okay, this means that we are multiplying or dividing by something. So in A, 2, 6, 18, 54, we're getting bigger, which means we are multiplying. To get from 2 to 6, we would multiply by 3. Multiply 6 by 3, we get 18. Multiply by 3 again, and we get 54. So I'm going to have to keep multiplying by 3. Now, I don't want this to take a long time, so please remember that you can use your calculator. So let's go 54 times 3. We get 162. Okay. Times 3 again, 486. And times 3 again, 1,458. Of course, you could get all of those numbers by doing long multiplication. Part B, we start with 256, and the numbers are getting smaller: 128, 64, 32. So because they're getting smaller, we are going to need to divide. To get from 256 to 128, we need to divide by 2. And we keep dividing by 2 the whole way down the line. So when we get to the 32, divide that by 2, and we get 16. Divide by 2 again, we get 8. Divide by 2 again, and we get 4. Okay, now there is no worksheet for this one. You will have to go to your exercise to practice this. So it's in exercise 8I, and there are some questions here for you to have a look at.